So in this video, I just want to walk through an example of how to apply the empirical rule to a particular type of problem. So I've kind of put together just a quick example here. And so the scenario here is that test scores for all math schools are normally distributed. So that's key. We know normally distributed with a mean of 85 and a standard deviation of 3. And we don't even care what they're testing. Let's just assume that we know all of that. But this is the data that we're given. So the question is, what percent of scores fall between an 82 and a 91? So in any of these problems, the first thing you want to do is you want to draw the graph out. You want to make sure that you kind of understand what things are looking like. And so we know that this is an empirical rule question. So, and we also know that this particular set of scores is normally distributed. So I can assume a normal curve. And we're given some information. We're given that the mean is 85. So I can draw that right in here. I know this is not the best color. Not too many colors to choose from here. So the mean is an 85. We can also call that mu because we're talking about a population. And now we know the standard deviation. So applying the empirical rule, we can actually figure out what one standard deviation out from the mean would be. So in this example, the standard deviation is 3, which means that one standard deviation out would put me at 82 to the left, and it would put me at 88 to the right. And so now I have one standard deviation, and we know that one standard deviation is 68% of our folks. If we did a random sample of the population, 68% would fall somewhere between 82 and 88. Now, so that's our 82 to 88. So if I go out one more standard deviation, and now you can see there's something here emerging. So the 82 kind of aligns itself with the question: what scores fall between 82 and 91? Well, the 88 doesn't match up to the 91, but let's go out one more standard deviation, and I'll just do it in a different color here. Try to pick one that is easy to read. So I'm going to go out one more standard deviation here, and that'll put me at 79 to the left and 91 to the right. Well, there's our 91 right there. So now that's 2 standard deviations. So we know, based on the empirical rule, that 2 standard deviations is 95%. So if I took a random sample, 95% of the scores taking that random sample would fall between 79 and 91. So we have 2 pieces of information here. I'm not even going to go out my 3rd standard deviation because we're only looking at the area between 82 and 91. So we're really only looking at this area right here. So we've highlighted kind of the area that we want to look at, and we know certain things. We know that the broader area is 95%, the smaller one is 68%. So I can actually figure out what the percent that falls between these 2 sections here, 79 to 82 and 88 to 91. I can figure out that percent simply by subtracting, and I'll just put it here, 95% minus the 68%, because that's the center stuff. We're just going to eliminate that, and we should get 27%. Now 27% is, and I'll see if I can try to find a color to color this in. I'll see. So this number here corresponds to this area and this area right here. But we only want the area to the right. So we need to take that and divide it by 2, which gives us 13.5%. So now I've determined that this is 13.5%, this is 13.5%, but we really don't care about the one on the left. And so now I can simply just add all the percentages up. So they're asking for the percent that falls between 82 and 91. So 82, we know that this part right here is 68%. And we know that this other part to the right of that is 13.5%. And so we know that the whole thing, if I grab a calculator, because I'm terrible with mental math, so 68 plus 13.5 gives us 81.5%. And so this is the percent of scores that fall between 82 and 91.